A signal is climbing out of the dark right now. It has spent almost a full day crossing empty space to reach us. Engineers open the stream, waiting for familiar numbers. Instead, the oldest traveler we ever built seems to answer in a language nobody expects. If stories like this pull you in, stay close and subscribe now. This is for people who want the real mystery, not fake space drama. And tonight, the truth is stranger than the clickbait. Voyager 1 is not a shiny new machine with perfect software and fresh parts. It is a spacecraft launched in 1977, when disco was still playing on the radio and most homes had no internet at all. NASA built it to study Jupiter and Saturn, not to survive for half a century in the freezing dark beyond the planets. But it kept going, year after year, long after the main mission ended, and now it is the farthest human-made object from Earth. That alone would make it special, but what makes Voyager 1 feel almost unreal is that it still talks back. When people hear that, they often imagine a strong, clean beam, like a live phone call from the edge of space. The truth is much harder, much slower, and much more fragile. Voyager 1 sends a tiny radio whisper powered by an aging nuclear battery, and giant dishes on Earth have to catch it from more than 15 billion miles away. That is about 25 billion kilometers, a distance so large that even light needs roughly 23 hours to travel one way. So every question takes almost 2 days to answer, which means every mistake, every mystery, and every fix moves at the speed of patience. That huge delay changes everything. If your laptop glitches, you restart it in seconds. If Voyager 1 glitches, you think for days, send a careful command, wait almost a full day for it to arrive, then wait almost another full day to learn if you helped or made things worse. And while you are waiting, the spacecraft is still flying deeper into a place no human being can visit, no repair team can reach, and no other working probe can fully replace. By the time Voyager 1 crossed into interstellar space in August 2012, it had already done more than anyone expected. Interstellar space sounds like it means it left the whole solar system behind, but the real meaning is a little different. It crossed the heliopause, which is the border where the sun's flowing particles stop dominating the space around us. Beyond that line, Voyager 1 entered the thin material between the stars. It became the first human-made object to do it, and for scientists, that turned the spacecraft from an old explorer into a one-of-a-kind witness. That is why every signal from Voyager matters so much. It carries clues about magnetic fields, charged particles, and plasma, which is gas so hot that its atoms break apart into charged pieces. Those measurements help scientists understand the shield around our solar system and the wild space outside it. Voyager 1 and Voyager 2 are the only spacecraft out there making those direct measurements. If one of them goes silent, it is not like losing a camera. It is like losing the only weather station on a distant coast that nobody else can reach. For years, Voyager 1 kept doing its job with almost stubborn calm. The team had already solved old problems before. In 2017, engineers even brought back a set of backup thrusters that had not been used for 37 years. That kind of rescue sounds almost impossible, but it worked. So by the early 2020s, the mission had a strange mood around it. Every new day felt both ordinary and unbelievable, like an old clock still ticking long after everyone expected it to stop. Then came one of the first big warning signs. In May 2022, NASA said Voyager 1 was sending strange data about its orientation system, the part that helps point its antenna at Earth. This system is called the AACS, short for Attitude, Articulation, and Control System. Scientists expected normal status numbers showing where the spacecraft believed it was pointing. What they got instead looked random, or at least wrong, like a dashboard calmly reporting nonsense while the car still stayed on the road. That gap between what the data said and what the spacecraft was clearly doing made people pay very close attention. And this is why that was so weird. If the orientation system had truly failed, the antenna would likely drift away from Earth, and the radio signal would weaken or disappear. But the signal did not vanish. Voyager 1 kept receiving commands, kept sending science data, and kept acting as if the antenna was still pointed correctly. So the old belief was simple: bad pointing means bad communication. The reality was harder. Communication still worked, yet the data describing that communication did not make sense. That meant the problem might not be the steering at all, but the messenger reporting what the steering system was doing. Did you expect the first crack in the story to be a machine that looks broken and healthy at the same time? If that surprise got you, tap like and tell me in the comments whether you would trust the signal or the behavior. And if you love real space mysteries like this, subscribe before we go deeper. At that stage, NASA did not claim aliens, hidden objects, or secret transmissions from deep space. The The mystery was far more technical and, because of that, far more unsettling. A spacecraft that old should fail in clear ways. It should stop answering, stop turning, stop sending science, or trigger a safe mode to protect itself. Voyager 1 did none of those things. It simply returned data that did not reflect any possible state the system could be in, which is a calm scientific way of saying the numbers looked impossible. Engineers still had hope because impossible numbers do not always mean impossible events. Sometimes the machine is fine and the record is wrong. Think of a thermometer that says a room is 500 degrees while you are standing in it wearing a sweater. You do not assume the air turned into fire, you assume the reading is bad. That was the team's first idea with Voyager 1. Maybe the system that created the report was damaged, even if the spacecraft itself still knew what to do. But solving that kind of problem from Earth is brutal. Voyager 1 has several computers, and all of them were designed in another age. The hardware is old, the memory is tiny by modern standards, and the code was written for a machine never meant to last this long. Also, space is not kind. Interstellar space has high radiation, and radiation can damage electronics over time. So every odd signal raised a wider question. Was this a small reporting error, or were they watching the slow aging of the farthest machine humanity has ever built? For a while, the mission kept going. The strange orientation data did not kill the spacecraft. But then, in late 2023, the problem became much more serious. Voyager 1 stopped sending readable science and engineering data back to Earth. The radio link was still there, like a phone call that had not dropped, but the useful message was gone. Instead of clear information about the spacecraft's health and what its instruments were seeing, the stream became gibberish. NASA later described it in a way that makes the whole thing easy to imagine. The line was still connected, but Voyager's voice had been replaced by a dull, repeating tone. Normally, digital systems send meaning through patterns of zeros and ones. Voyager 1 was now sending a pattern that did not help scientists understand the spacecraft or the space around it. That was the real crisis. A mission can survive confusing numbers. It may not survive months of unreadable ones. And remember what made this worse. Voyager 1 was already more than 15 billion miles from Earth when this happened. One command took about 22.5 hours to arrive. Then the answer took about 22.5 hours to come back. So every test cost nearly 2 days. The team could not just try 50 things in one afternoon. They had to think like surgeons. One move, then silence, then one answer, then another move. What scientists expected was this. If a software section had glitched, maybe a reset, a reroute, or a forced action could shake the system loose and restore normal output. What they actually found was more stubborn. The bad signal kept coming. No science data, no clear engineering report, no easy clue telling them which exact part had failed. And that gap mattered because if they could not identify the sick part, they could not safely avoid it. Months passed. To the public, it looked like Voyager 1 had become a ghost at the edge of the solar system, still there, still answering, but saying nothing useful. To the engineering team, it was something more frustrating. The spacecraft was alive enough to hear them, alive enough to react, alive enough to keep the antenna aimed well enough for a stable signal, but not healthy enough to explain itself. That kind of half-silence is often worse than total silence, because it keeps giving you hope while hiding the exact problem. Then came the part many people still do not know. In March 2024, engineers sent what was basically a careful poke. Not a random guess, but a command meant to push Voyager's flight data system, called the FDS, into trying different software paths. The FDS is one of the main onboard computer systems. It handles how data gets packaged and prepared for transmission. If the spacecraft is a storyteller, the FDS is the part that puts the words in order before they are spoken. The poke did not solve everything, but it changed something. A section of the signal started to look different from the rest of the unreadable stream. At first, the team did not know what they were seeing. Then an engineer working with the Deep Space Network decoded it. What Voyager had sent back was a readout of the entire FDS memory. That was huge. For the first time, the spacecraft had not fixed itself, but it had exposed its own wounded brain for inspection. Here is where the mystery became both clearer and stranger. Scientists originally feared a broad failure, something spread through the system in a way that might be impossible to work around. What they actually found was more specific. About 3% of the FDS memory had been corrupted. That may sound small, but on a spacecraft this old, even a tiny damaged part can break a critical chain. NASA believed one chip storing part of that memory was no longer working as it should, and they still could not say for sure why. That last point is important. By spring 2024, the team had a likely technical cause. They did not have a final answer for what created it. Two big ideas stayed on the table. One was age. After more than 46 years in space, the chip may simply have worn out. The other was radiation. An energetic particle from space may have struck the hardware and damaged it. So yes, the signal mystery was partly explained, but the deeper question of why the failure happened remained open. Do you think a machine dies more from one sudden hit or from decades of slow wear? Leave your guess below, hit like if this feels like science fiction made real, and subscribe if you want the next turn in the story. Because the fix NASA tried next sounds almost impossible. Voyager 1 has no repair dock, no backup spaceship, and no human hands waiting nearby. So the team had to do something wild. They decided to move pieces of the damaged code into other places inside the FDS memory. Imagine an old library where one shelf collapses. You do not build a new library. You carry the surviving pages to other shelves, rewrite the catalog, and pray the book still makes sense when someone opens it. That is close to what NASA was doing, except the library was 15 billion miles away. This was not one quick patch. Different code sections had to be divided up and stored in different memory areas. Then the team had to update the rest of the system so it knew where those sections had gone. If one part of the program still pointed to the old broken address, the repair could fail. So they started with the part that packaged engineering data, the numbers that tell Earth how the spacecraft itself is feeling. That was the smartest first target. Before you ask a patient to run, you first need to know the patient is alive. On April 18, 2024, the command went out. Then everyone waited. Because of the light time delay, the answer could not arrive until April 20th. When it did, something wonderful happened. For the first time in 5 months, Voyager 1 began returning usable engineering data again. Not the full science story yet, not a perfect cure, but the old spacecraft was making sense again. Its health and status could be checked instead of guessed. That moment matters more than it may seem. People often think the big win in space is dramatic discovery. Sometimes the real win is getting a machine to say, "Here is what hurts." Without engineering data, scientists are almost blind. With it, they can plan the next step. So the pattern repeated again. Expected. Maybe the craft was too damaged to recover. Actual. A partial software rescue worked. Why it mattered. A one-of-a-kind mission moved from panic back to possibility. And NASA did not stop there. In May 2024, engineers sent another command so Voyager 1 could begin returning science data again. 2 of its 4 operating science instruments came back to normal quickly. The other 2 needed more work. That detail is easy to skip, but it shows how delicate the repair was. The spacecraft was not a light switch that could simply be turned back on. It was more like an orchestra that had lost pages from its score and needed each section guided back in carefully. By June 2024, all 4 operating science instruments were sending usable science data again. That meant Voyager 1 had returned to normal science operations after the late 2023 computer trouble. Those instruments were studying plasma waves, magnetic fields, and particles in interstellar space. For most missions, getting data back after a failure is nice. For Voyager, it is priceless. There is no replacement probe sitting just beyond it. There is no second copy of its exact path through this exact region of space. Every restored bit is a recovered piece of the universe. So was the unexplained signal fully solved? Not in the simple way headlines suggest. The garbled data was traced to corrupted memory in the flight data system. The team learned how to work around the damage. But the spacecraft still raised hard questions. Why did that chip fail when it did? Was the trigger age, radiation, or something else? And how many more unknown weak points are waiting inside a 1977 machine now living where no repair mission can go? This is the detail most people miss. A spacecraft like Voyager 1 does not fail once. It fails in chapters. One year, the problem may be orientation data that looks impossible. Another year, the problem may be unreadable engineering and science data. Another time, the issue may be power, heaters, or radio systems. Each new signal has to be judged against the whole history of the spacecraft. That means engineers are never solving one mystery. They are living inside an ongoing series of them. And the story did keep going. In October 2024, Voyager 1 briefly stopped using its main radio transmitter after what appeared to be a fault protection response. That kind of protection system is meant to defend the spacecraft when something seems wrong. Later, NASA said the mission had resumed regular operations. So again, the pattern returned. People expected smooth contact after the 2024 repair. Instead, the spacecraft found another way to remind everyone just how thin the line now is between normal and trouble. Would you still call Voyager 1 working fine after hearing all of that? Tell me yes or no in the comments, and if this old spacecraft has already earned your respect, tap like and subscribe. Because the next part is where the mystery stops being about one strange signal and becomes a countdown. The biggest enemy for Voyager 1 now may not be one broken chip. It may be time itself. The spacecraft runs on a radioisotope power system, which turns heat from decaying plutonium into electricity. Every year, that supply drops by about 4 watts. 4 watts may not sound like much, but on a machine already operating on thin margins, it is everything. It means something has to be turned off, then later something else, then later something else again. That is why NASA has spent years making hard choices about what to keep alive. Heaters have been reduced. Old systems have been shut down. Instruments have been turned off in careful order. The goal is not comfort. The goal is survival. Engineers have to save enough power for the parts that still bring unique science back to Earth, while making sure the spacecraft does not get so cold that important lines freeze. In February 2025, one of Voyager 1's instruments, the cosmic ray subsystem, was turned off to save power. Then in April 2026, NASA shut down another instrument, the Low Energy Charged Particles Experiment, usually called LECP. That instrument had been working almost without interruption since launch. It measured ions, electrons, and cosmic rays from our solar system and our galaxy. Losing it was not anyone's dream choice. It was a survival choice made so the spacecraft could keep living a little longer. NASA said Voyager 1 still had 2 operating science instruments after that, one listening to plasma waves and one measuring magnetic fields. Those are still working and still sending back data from a place no other human-made craft has reached in the same way. But read that again and feel what it means. This is not a stable machine with extra room. This is a mission trimming itself bone by bone just to keep a heartbeat. Every new strange signal now arrives in that context, which makes each one more serious than it would have been 20 years ago. There was also another warning wrapped inside the 2026 update. During a planned roll maneuver in February 2026, Voyager 1's power levels dropped unexpectedly. That is the kind of small sentence that mission engineers never treat as small. If power drops too far, the spacecraft's protection systems can shut parts down on their own. That kind of automatic shutdown may keep the probe safe, but recovery can take a long time and carries risk. So the team acted before that could happen. In a mission this old, control is not about comfort. It is about staying one step ahead of failure. Then came one of the most daring ideas in the mission's late life. Engineers talked about a deeper energy-saving change nicknamed the Big Bang. The name sounds dramatic, and it is. The plan is to swap out a group of powered devices at once, turning some things off and moving to lower power options so the spacecraft stays warm enough and stable enough to continue gathering science. If that works, it could extend the mission. If it fails, the cost could be very high. That is the kind of decision you face only when every spare watt has become precious. Now step back and look at the pattern that has unfolded. Scientists expected a retired planet probe to maybe survive a little longer than planned. What actually happened is that Voyager 1 crossed into interstellar space, kept sending science for decades, developed weird signal problems, partly recovered, then entered an even tighter fight with power loss. Why does that gap matter? Because it shows that our machines do not just explore space, they age there, they improvise there, and through the people who operate them, they are almost taught to survive there. This is where the story shifts from what happened to what is happening now. Right now, Voyager 1 is still moving outward. Right now, each message still crawls across nearly a full day of space before it reaches Earth. Right now, engineers are still balancing science against survival, trying to keep the last useful instruments alive as long as possible. And right now, every odd bit of data carries 2 possible meanings. It may be the next small problem they can outsmart, or the first sign that the long, final silence is getting close. There is another reason this story hits so hard. Voyager 1 is not just far away, it is far beyond help. If a Mars rover gets stuck, we still dream about future missions reaching Mars. If a satellite in Earth orbit fails, another spacecraft may replace it. Voyager 1 is different. Nothing is going out there to repair it. Nothing human will catch up to it soon. So when the signal turns strange, the feeling is not just technical worry. It is the feeling of hearing an old voice fade from across an impossible distance. Did you ever imagine that one broken chip could matter this much to our picture of the universe? If that thought gives you chills, leave a comment, hit like, and subscribe for more stories where the science is real and the stakes are bigger than they look. Because the last part of this story is not really about hardware at all. Voyager 1 carries a golden record, a message from Earth meant for any distant intelligence that might someday find it. People love talking about that record, and for good reason. It feels poetic. But the more powerful message may be the one Voyager is sending us right now without meaning to. It tells us what human curiosity looks like when it refuses to quit. A machine built in the 1970s is still teaching us about space between the stars, still forcing us to solve new problems, still making engineers reach across billions of miles with code and courage. That matters on a human level. Most of us will never work on a deep space probe. Most of us will never decode a memory dump from interstellar space or decide which instrument must die so another can live. But we do understand what it means to keep something going past its expected life. We understand patching, adapting, choosing what matters most, and trying again when the easy path is gone. Voyager 1 turns those human habits into something cosmic. That may be why people care so much when its signal goes strange. It also matters for the future. One day, new missions will travel even farther, maybe to the outer edge of the solar system faster than Voyager did, maybe beyond it with better power systems and smarter computers. When they do, they will carry lessons bought by this old probe. How do systems fail after decades in deep space? How do you design software that can be moved around damaged memory? How do you plan for radiation, low power, and delays that make quick fixes impossible? Voyager 1 is not only discovering interstellar space, it is teaching us how to survive there. And still, the deepest emotional truth is simpler than all of that. Voyager 1 is alone. No crew, no rescue ship, no cheering crowd around it. Just a small machine, a dish antenna, a fading power source, a few still working instruments, and a whisper crossing the dark toward Earth. When that whisper turns weird, the whole planet leans in. Not because we think it is magic, but because we know how rare it is. It is one of the last direct threads connecting us to a place no person has ever seen. So when a headline says Voyager 1 detected a signal scientists cannot explain, the smartest response is not blind belief and not smug dismissal. It is curiosity with context. Some parts of the mystery really have been explained. The bad engineering and science data were linked to corrupted memory in the flight data system, and NASA found ways to work around that damage. But some parts remain uncertain. Exactly what caused the failure may never be proved, and every new odd behavior from now on arrives on a spacecraft living at the edge of its power and age. That is what makes the story bigger than one glitch. Voyager 1 is showing us the final stage of exploration, when discovery and decay happen together. The same probe that reveals the space between stars is also revealing what half a century of deep space survival does to a machine. It is science and aging in one frame. It is triumph and fragility traveling side by side. And because the signal delay is so long, every answer from Voyager feels like news from the past arriving just in time to change the future. If you were on that mission team, what would you protect last? The instruments, the heaters, or the radio voice itself? Drop your answer in the comments, and if you want more true space stories told simply and clearly, subscribe and turn on notifications. This channel is for people who still feel something when the universe whispers back. Maybe the strangest part of all is this. Voyager 1 was never built to become a symbol. It was built to do a job. Visit giant planets. Send data. Follow commands. Yet over the years it has turned into something larger in our minds. Not alive, not aware, but still carrying a shape of our own stubbornness. When its signal breaks, it feels less like a tool failing and more like a chapter of us becoming harder to hear. And one day, that chapter will end. The remaining instruments will go quiet. The power will drop too low. The carrier signal itself will fade. Earth will send commands and no useful answer will come back. Voyager 1 will still exist. It will keep moving through the dark for thousands of years, but the conversation will be over. That is why every strange signal now matters so much. We are listening during the final pages of the longest distance conversation humanity has ever had. So before that day comes, pay attention. Subscribe, turn on notifications, and stay with us for the next message from the edge. Then tell me in the comments what you think finally ends Voyager 1. Power loss, radiation, or one more mystery no one sees coming. And share this with someone who still looks up and wonders what is waiting in the dark. Thanks for watching, and I am really glad you were here for this one.